with the interior and exterior angles of convex polygons. We have dealt with the interior angles of triangles before. We know that for every triangle, there's 180 degrees. We have dealt many problems with triangles, interior angles. We know that the sum of the interior angles of a triangle is 180 degrees. So we can use that to figure out the interior angles of other convex polygons. So if I take a vertex and I just draw the diagonals from that vertex. So remember, a diagonal is connecting non-consecutive vertices. I have a 1, 2, 3, 4, 5-sided polygon here, so a pentagon, and I created 1, 2, 3 triangles out of this pentagon. So for each one of these 3 triangles, I have 180 degrees. Let's go down here and fill in our formula. I had 5 sides. We're going to use in to represent the sides, but I only had 3 triangles. So I have to subtract 2 from my number of sides to get how many triangles I create. And then for each one of those triangles, there's 180 degrees. And let's make a note. In represents the number of sides. So now let's use this formula to solve for the number of sides in this convex pentagon. So I have n minus 2 times 180 degrees. There's 5 sides. 5 minus 2 is 3. 3 times 180 is 540 degrees. So I have 540 degrees in my convex pentagon. Now let's take a look at problem number 2. We want to find one interior angle of a regular polygon. Now we know that regular polygons, all of the sides and all of the angles are congruent. So since all of the angles are congruent, I just need to take the sum, the total that I found, and average it. So how do we do that? Well, we just take our total, n minus 2 times 180, and how do you find an average? You divide by how many things there are. There are n angles. So let's use this formula to figure out the measure of one exterior angle of this regular polygon. So I have n minus 2 times 180 over n. So in this case, let's figure out how many sides I have. I have a 7-sided figure, so a heptagon. Seven minus 2 is 5. 5 times 180 is 900 degrees. Divided by 7 is approximately 128.57 degrees. So each of the interior angles of a regular heptagon is approximately 128.57 degrees. Again, 2 decimal places is a good place to be. This said tenth, so you could have rounded to 0.6, which would have technically been a tenth. Okay, now let's talk about the exterior angles of a convex polygon. This is the easiest formula you'll probably learn all year. The total for the exterior angles of any convex polygon is 360 degrees. It just is 360 degrees. Now, just like for the interior angles, if I want to find one of these angles for a regular polygon, I just average it. So I take the total, which is always 360, and I divide by how many there are. There are n angles, just like they're in sides. The number of sides, the number of angles are always the same. So,
please excuse the interruption and this.
to find the measure of one exterior angle of this regular polygon, we first need to know how many sides it has. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have an 11 gone here. We know that the sum of the exterior angles is 360 degrees. And we know that we're just going to divide this by the number of sides to figure out the measure of one of the exterior angles. So 360 degrees divided by 11 gives me 32.72 with a line over the top degrees. So that 72 repeats forever. So each one of the exterior angles, and then I want to make one last point about the difference between interior and exterior angles. So I'm going to change my pen color just so I can be clear. Interior angles are just as they sound on the inside. Interior, inside. Exterior angles. It's a little different than an exterior angle, and the difference is that it's not the whole thing on the outside. An exterior angle, you continue your line, and then it's what would form a straight line with your interior angle. So it's the supplement of your interior angle, and you go all the way around your polygon, and these angles that I'm marking, those are your exterior angles. You have to go all the way around. So those are my exterior angles. Not everything that's on the outside. It's the supplementary angle to the interior. So as you can see, if I take yet another pen color and I mark the interior angle, this interior angle forms a straight line with the exterior angle. So they add to 180. They are supplementary.